you all for coming. Excited to talk to you today about clouds. Not the outside kind, data clouds. So I am Amber. Big shocker, you know that. I've been doing digital forensics for over 30 years at this point. I've owned my own technology company for 26 years. And I do have to say that this is probably the most exciting field in cyber because it is changing every day. We're seeing more adjustments to the type of data that we're looking at, to new techniques. AI is really making some changes in our space and how we're able to go through different pieces of data. For today, I'm really going to focus on the cloud side of it. Our first in this series was focusing on smartphones, and our last in this three-part series is going to focus on IoT in December. So make sure you sign up for that session as well. So what I'm going to cover today, we're going to go through our current challenges, because if we know those, then we can educate ourselves and then get adjustments into what our workflows are going to be, etc. We're going to talk about the scope of the cloud, since we have multiple types of cloud that you have to deal with when you're doing an investigation, what our capture methodology is for that data associated with the cloud. And the last one, we're going to review some of the tools and techniques that you might use in order to be able to capture the most data from the cloud. I do think out of all of the disciplines in digital forensics, cloud and IoT are probably changing the most because they're the newest in the field. We've been capturing computers for a very long time. That was kind of the foundation of the space. And then obviously when we had smartphones emerge, that became the new focus, believe it or not. That's kind of your primary piece of evidence. And now, of course, smartphones connect to cloud and connect to IoT. And so we have to look at those areas. So our first thing we're going to talk about is probably the biggest problem, which is consent. So legally, and this is pretty global at this point, we haven't had a lot of precedents occur when it comes to the cloud and the law. So we haven't said, hey, every time you capture cloud, it has to be done with this technique, or you're always entitled to cloud data when you're doing a forensic investigation. And so we get into some of that gray area. The answer to that gray area, and remember, I'm not a lawyer, I'm just a nerd, is consent. And consent is something that we have started to gather in order to be able to capture from the cloud resources, because whether you're law enforcement or private sector, it's easier to just go with this as your default, as opposed to, oh, I need to get another warrant, or, oh, I need to go through an additional process over here. If you capture with consent, you know it has to be voluntary. You have to inform them of what you are actually doing and capturing with it. You can't coerce them into doing it, of course. And then you have to have some documentation that allows you to go through and show that they have done all of this process. One of the unique parts, if you're on the other side of a collection for cloud, is you also should go through and put through a scope or a capacity of what they're going to capture with it. Because cloud isn't about an individual incident, it's about an entire existence within a storage space. And so being able to scope it down into what you're actually allowing to be collected is a big deal. And it does change some of the things with consent. So I think that's an important aspect for it. And then, of course, make sure that you have the appropriate legal authority. That's where you should reference over to an attorney and ask how they want it to work with. I'm going to give you kind of a generic path to follow, and then you would want to make sure it matches whatever your local laws are associated with you. So the big thing on consent is you do need it for everywhere, because we're going to talk big cloud, little cloud, and all the cloud in between. Realize that you do need to have that consent for everything. So if you're going to go big cloud and you're looking at something that might be in Microsoft Azure, you need to have the consent of the corporation you might be looking at and have those appropriate pieces of documentation. I, as an individual, might have an Azure account. Again, your consent should be similar for me as an individual as it would be for a corporation. You also need to have it for individual devices. Since our first in the series was about smartphones, obviously that might be associated with your iCloud with an Apple device, or your Google Drive with an Android device. You have OneDrive, Dropbox, numerous different apps that are all cloud-based. You would need consent that either is specific for each one of those, or have them do it for a generic, I give you consent to anything that collects from the cloud. So you do need to make sure your documentation is appropriate. So this is kind of what consent looks like. This is a really, really basic consent form. I use this all the time when I'm doing professional consulting work. So I'm working on the private sector side. I make sure I have consent, and I also have them provide my their credentials for that cloud storage as part of the consent process. Now, does that mean they're always going to provide the correct credentials? No. A lot of times people forget what those are and we go back and forth with it. But once I start with that initial consent, then I can kind of modulate what I need as I go through and do my different collections. But it does start initially from consent. The next stage that we would go to is we start about the overall scope of what cloud forensics is. Now, this is very similar in process to what we see when we do smartphone forensics or computer forensics and we work with file system data, or as we will see with IoT forensics. But cloud forensics starts with the same things. We first always identify what we're going to capture. Are we capturing large cloud, big cloud data? Or are we capturing small cloud data, looking more on the app side of things? Is it public? Is it private cloud? That's my identification stage. That's where consent really comes in play. Then the next side of it is based on the type of cloud I'm going to connect. I'm going to do the scope of it. And we're going to talk a little bit more about that. The biggest thing with scope on this one versus looking at a smartphone is that our scope can be very, very large. So we can be looking at a petabyte of data that can be cloud-based, where I'm not going to see that on a smartphone because it just is not possible. Well, the last couple is our protection, of course, we have to change our techniques that we're going and doing our collection with. And then the last is collection with our capture and our analysis. These rules that I'm giving here are generic. It does not matter what type of tool or technology you're using. These are the foundational rules that you have when you're doing a cloud investigation. So let's talk about our two clouds. So I've said big cloud, little cloud. It's also private cloud and public cloud. Now it's private and public, and I have the quotes around public because it's not actually public. The big difference is it doesn't have a separate service contract with it, and that's kind of where you draw your line between your two cloud spaces. The other is when we look at our private cloud, you'll see the logos for like AWS or Azure or Oracle. That is where we get a little bit larger scale. So that's where we have that potential of a petabyte of data. Where if we go over to the public side of things, we're looking more app oriented. So we're having more of like personalized storage as opposed to corporate storage or public sector storage, larger scale on the private side. So let's start talking on the private cloud side or on our big cloud. So big cloud is when we start breaking into that larger storage capacity and we have more infrastructure storage associated with it. So here's an example here with Microsoft Azure. So the big note I have with large cloud or big cloud is they have the worst interface on the planet. So it's almost like when you're going and using Netflix and it changes its interface and you're so frustrated with the change. You see that happen as well when it comes to the big cloud interfaces because it's a large console to an entire structured environment. It's not always the easiest to navigate through. But this is actually where you start your investigation from. You start it from two different places. I brought the consoles up because I think this is a great place because again, you're working with consent. They're allowing you to log into their console. This is where you're going to see what kind of services they're using, what kind of data they potentially have up here, and then you're going to start making your decisions on what the scope, so your second step of the process is going to be. After we look at Azure, we can look at AWS, and I'm going to go into more steps with AWS as my example, simply because I think it is a little bit more common for everyone. So I think it's the easiest big cloud to look at. So when I go through and I do an AWS investigation, the first thing I start is I either start with a bill they provide to me or I start within their billing console. And I know you're probably thinking, why do you care about how much they're paying for their AWS? Well, everything in big cloud has a fee, like everything. I think if you like sneeze in there, it costs you money. So if I know what they're paying for, I know what I'm going to potentially collect. And I know it sounds like a very different methodology for you to go through and do a collection this way, but it's hard to tell the scope of someone within a large cloud environment. So this is the easiest way to kind of get your checklist that says, oh, hey, wait, they have 5 S3 buckets or they have 6 virtual machines in here. That's providing you what their scope and their architecture is within it and potentially how they're using that big cloud. So I always start at the billing console. This is what it looks like when If I didn't have a billing console access, I might go through their email and see they have an AWS bill, which tells me I have an additional collection site. So here's an example of what I would see in an AWS bill. Again, it's breaking down the individual storage areas that I would have available to me, and I'm going to make a collection choice at that point. So this is breaking down an AWS bill for you. So we have this simple storage service. This is a good example for you. So it's a great time to, if you're doing AWS, these are great screenshots for you to have, where it's telling you what type of objects they have, what type of capacity are they using. You know you have a maximum of 5 terabytes within this area. That's still a lot of data that you have to plan on collecting. You see the data transfer. This is going to tell you if potentially there was an incident, you saw a large data transfer happen at an individual time. It's going to have logs that gives you all of this information. Again, you cannot do anything in Big Cloud without paying for it. So they have excellent logging for you to kind of work your investigation on. Then we have our S3 area. This is our buckets associated with AWS. So these are our primary storage areas. That's where we're going to see our data we want to actually go through and do our analysis on. There's a couple different ways we'll talk about collecting that as well. And it can be glacial storage, or it can actually be live S3 buckets. Glacial storage is just longer term storage that doesn't have the same quick accessibility to it. So it's cheaper in AWS. It doesn't mean it isn't forensically viable for us. We just then have to pull it out of that storage in order for us to gain access to it. This is some of that cost explorer that you might see associated with it. This is telling you what their average are per month. So this is where you're kind of getting a roadmap of where maybe their data points change dramatically. That's also going to help you when you're starting to do your investigation. And then this is where you start getting into those loggings. So with AWS, we have kind of a trail. It literally is called that, where it has multiple types of logs associated with it. I capture those first. So as I start designing what my scope was going to be, I'm kind of seeing their pattern of use. This is actually a really good area is to use AI in, is because you can take a bunch of these different logs and AI is able to go through and identify different patterns. Now, if I'm using AI to do cloud forensics, I want to make sure it's designed to do forensics in the first place. So it has to be private. I'm not going to go and dump all these logs into ChatGPT and say, go at it. That's not following your forensic rules. So make sure it's a private environment. But logs are one of the greatest things for AI ever. It saves you so much time because it's able to do much faster analysis on large data logs like this. Then you can also see where the logs are stored. Of course, they're going to be into a bucket because that's the primary storage in AWS. And you can do analytics in there. I don't recommend that because it's not seeing the data the same way that you want to see it in digital forensics. Our next area of our bill, of course, is when we start getting into the Amazon Elastic Compute Cloud, the key management, and the virtual private cloud. So these are 3 different areas, again, that are telling you your architecture of how your potential suspect or the organization you're investigating are using big cloud services. So keep this in mind because this is telling you some of the virtual machines that they might have accessible up there, and it's giving you kind of your plan of attack. Again, you have to map all this out first before you start doing any of your capture. So when you go through and actually do your capture, these are the questions you're going to ask yourself. So what are you entitled to within all of this data? Because again, you had a section of it that was its maximum size was 5 terabytes. That's a lot of data to go through. So you're going to figure out based on doing all of that mapping. I was just talking about using what their bill was, what their logs are associated with it. And you're going to figure out within your consent, what limits are you going to do on what you're going to collect. The next thing you're going to do is how are you going to download this? So that's the biggest change you have with big cloud versus little cloud. Because it has a larger storage capacity and it's sitting in a large cloud environment, is typically you work within that environment. Whenever I'm doing an investigation in AWS or Azure or any of the other large clouds, everything I do is staying up in that environment. The reason is typically my scope is rather large with the data, and I'm setting up a forensic virtual machine within that environment so it can interact. As soon as I decide to pull down terabytes of data or bring that data down, it's going to be having a very large overhead associated with it, because that's one of the areas that cloud makes a lot of money, is when you pull your data out of the cloud. When you work essentially horizontally within the cloud, so I'm working in a virtual machine within that same environment and doing my analytics or making copies of my buckets or my forensic images of those buckets, those things are just looking at larger storage bills, but they're not in the transfer. It's actually cheaper to do it that way, and it's much, much faster because you're really just virtualizing within the same environment. And then the other side is if you're going to have to do a remote capture. So it's similar to how you would do a remote capture on a network. You're just going to do it in a virtualized cloud environment. Like I said, you're actually working and functioning within that cloud as well. So being familiar with our two largest, we're going to say AWS and Azure are our two largest. That's a good thing for you to kind of practice and get familiar with. A lot of them, they have trials associated with it where you can kind of build your own little environment and practice with it. I highly recommend it because it's very hard when it's the first time and it happens to be a case that you're working on. It's not a pleasant experience to have that level of anxiety. So after we've decided all these things we're going to collect, we kind of move from big cloud, because we know we have to work within that cloud environment, into our little cloud. When we start working with a little cloud, we hit that next step in our forensic workflow, which is really the protection step. The reason we have this, which is different than what we would have with other types of forensic acquisitions, is because we're having to go to a data source that we don't control. That's the hardest part of it, is you're having to go to some other place on some other computer, and that's where all of your forensic data is. But you have zero chance of ever interacting with the machine physically, so there's no write blocker associated with it. Instead, you have an issue where you're going to potentially lose access through your IP address, and it's going to block you out, because you're doing something beyond the original scope of what that cloud environment is designed for. The cloud environment really is to push up to and do minor queries down from it. It's not designed to push up to a key and then pull massive data down from it. So it starts getting a little bit suspicious of those activities. One of the things you do within the forensic process is you protect your IP address with either a VPN or with a proxy server. Then you have your tool that you'll use at the forensic lab. You'll have the keys or credentials that have been provided from you, and then you're going to query up to the cloud and pull that data down. Once you have that, you have three ways that you're going to do that. You're either going to do it through known credentials, like you saw from my consent sheet, where someone has provided you those details to be able to log into their cloud environment. You can capture credentials. So let's say I've done a forensic investigation of a computer or a smartphone, and you've captured cloud credentials from those particular devices, or they're going to do a live consent from them. So we're going to talk about each of these three methods to be able to capture cloud data from Little Cloud. So token collection is an interesting one, because this will vary based on the type of tool that you're using within your forensic choices. So a lot of them should be providing you tokens or authentication keys. Those are embedded within the devices as the suspect or the end user has used those devices. They've logged into their cloud environments. They leave their keys behind. Not a big shock to any of you that there are tons of little breadcrumbs left behind for forensics to pick up. One of these is the authentication keys and tokens to someone's cloud. The other choice, of course, is consent. I would take those tokens that I have from my other forensic investigation. So it's a smartphone collection. I would take my authentication tokens that my tool has recovered. I'd take my VPN, I'd have it running, I'd use those tokens, and it would authenticate into their cloud, because it really just looks at my tokens as a spare key to their cloud. It's just like if you had a spare key to your house or to your apartment. You can't tell the difference between the original key and the spare key, and neither can the cloud environment. So it looks at you the same as the end user. When you use those authentication tokens from a computer, you have different limitations. It's not quite as open on dropping all those little breadcrumbs of the tokens. My example is with the tool that is one that I design and use, of course, because I'm the architect for it. But we go through and we can find keys for like Slack or for Twitch or for Discord. Those get dropped on a computer, which is a more common use case, because those are common tools that you use on a computer of some type as opposed to a mobile device. They happen to leave the cloud keys behind, and we can capture that information. You also can capture some of those cloud key information pieces from, for example, Chrome, which drops a lot of keys or people use as their password manager. Now, a token and knowing someone's credentials are two different things. The token is typically already authenticated, so it's a lot easier to gain access into the cloud. Where knowing someone's keys, you still have to type them in. You typically hit a two-factor authentication, and you have to go through a couple extra steps within the process. When you go through a mobile device, those are typically authentication tokens, which means they've already been authenticated. Typically, they will bypass over two-factor authentication associated with it, and then you can log into those cloud sources. Now, when you're going through a mobile device to get those authentication tokens, you have to have root level access on an Android device, or you have to have the equivalent associated with your image, or you have to have an encrypted iOS backup in order to capture those keys. For iOS, it's part of your keychain data that you can capture with your imaging. That does not require a full file system image when you're imaging an Apple device or an iOS device. It simply requires you to activate the encryption mechanism so you can collect those keychain data files. So let's look at some examples. So here's a big cloud capture. And I know you might not be able to see 100% of it. The big thing is that you see a structure here. So it's typically going to be either an S3 bucket, which is going to just be like a large data dump. Think of it as almost like a huge zip file. It's just not compressed. The other is that you're going to see a virtual machine. So you're going to see typical partitions. You're going to see either a Windows virtualization, or you're going to see Linux often, or maybe Unix as one of your options, but you're going to go back to that core knowledge you have within file system investigations. So you're going to see partitions, you're going to see file systems, you might see the MFT associated with it, and you're kind of going to do your analysis the same way as if you would do it as a computer. So that's your data expectation. If it's a bucket that you're looking at, or a blob with Azure, then you're going to look at large amounts of just data files. That's when having a functionality where like your tool will go through and sort through the data. So it identifies it by header and gives you categories for it. It makes reviewing that type of data much easier. If I have a smartphone and I've got a token capture, typically you have to take that outside of your case that you're doing your original smartphone from, because you're going to a secondary data source. Technically, you're doing a secondary investigation, so you wouldn't do it all within the same step. You want to be able to bring those keys back in and then limit your scope on how you're going to end up collecting it. You might see interesting things associated with the key more on the smartphone side than I've seen on the computer side, because smartphones are one of those things you can pass around to other people. They might use it quickly. Their significant other might say, hey, let me just log in and check my Gmail real quick on your phone, or whatever it may be. And so you would, when you process through those tokens, you might get tokens that are outside of your scope. And that's what I have as an example up here on the screen. We have David's tokens and we have Nikki's tokens. Just because we have someone's tokens, remember you don't necessarily have scope or consent to be able to capture the additional tokens from the device. So you would want to unselect those and only capture what is appropriate for it. Once you have those captured, you see on the bottom of the screen there, it says authenticate. That's where you make sure you have your VPN running before you go up and query into the cloud. Nothing sucks more than to get your IP address blocked. This is where your scope changes. Again, our second step of our process, where you can change it from a date range. Remember, when you collect from cloud, whether it's big cloud or little cloud, you're collecting an entire range. So it's everything from the point they started that account until the day that you're getting your tokens and starting your collection. Much larger scope than what might be relevant to your investigation. Your cloud tools that you're using to do your collection should allow you to limit that scope. Because if they don't, there's not a lawyer on the planet that's going to say, go ahead and take everything. It's 20 years of Gmail data. It doesn't matter. They're not going to say that. They're going to want you to limit it within the scope of where the investigation timeframe is. And you can typically also limit the scope based on the type of data that you're collecting. If you're part of a forensic investigation or a security team, make sure you remember that, so when someone does an investigation potentially on your group, or there's an incident that happens that you need data collected on, you know how you can limit your scope as well. Once it's captured, we're going to see very similar information that we would see if it was a localized app. The difference is on Little Cloud, a lot of the apps have started to migrate their primary data stored into the cloud. They do that so as firmwares change on our smart devices, they don't have to constantly keep updating the way their structured app works. And so they've moved their data into the cloud. Twitter is a very good example of that. Facebook Messenger has the option to either keep it local or move into the cloud. Facebook will have a mix of data between the cloud and the app, where you'll get different data stores based on each one. Let's look at a couple other examples. So this is Slack data. So Slack, for example, I figure that's a very common app that many of you might use. We'll have everything from the members list to public and private information to channels to direct messaging. All of that can be collected. When we actually have that collected, the big thing you have to know before your collection on Slack is you have to understand what channel you're actually collecting from. So again, understanding that context of what the app is and how it functions, or the tool is and how it functions, is really important when you start just collecting the data from the cloud, because it's going to adjust that scope. Another example within Slack. And then our last collection area. So if we don't have credentials from a computer, we don't have credentials from a smartphone, and they're not sure if they want to have consent, a new methodology that has happened is a lot of the live capture. This allows you to work with people in the field working on maybe individual interaction with potential suspects, and then people working within a lab environment. They can actually set up a session where they create a direct secure link, so people can go in and say, hey, I want to connect and have you interact with the person. They're talking with your potential suspect. The suspect says on scene, I agree to consent to my cloud sources. Here, sign this form associated with it. And they literally sign within a little link in their app. They add their credentials that they're going to believe are correct. This is nice when you're live, because if they're wrong, you know almost instantly. That says, it looks like that isn't your password to Discord. Would you like to input it again? Perhaps you mistyped. You can have a direct feedback, and you don't have to continually go through it. This is very common within law enforcement. They will do this as well. So once they put the different credentials in for it, you can go through and start import. You have the same capabilities where you can limit scope, or you can capture it all, but the difference is you have a lab working with someone in the field all at the same time. And it is fairly quick to be able to do the collection. So that is kind of trended up in popularity as well. My last area before we go to questions is actually our last cloud source. I didn't have it in the original chart, but this is becoming probably one of my favorite pieces of data, which is compliance data. The reason is globally, we've all started to take our privacy a little more valuable than what we did originally. And so as part of that, we're having regulations come out. Good example, GDPR within the United States, we have the California Data Protection Act, and we have it in the US based on state. Globally, a lot of countries are deciding to adopt something similar to GDPR, so the Global Data Protection Regulation, I think. I always get my acronyms wrong. That is where compliance data comes from. So this is where you have cooperation of the person that you're collecting from. So this is another form of consent. The difference is they're actually participating through the entire process. This is when they can log into the account. Typically, you go into security settings associated with your account, and you can do this with a lot of different apps out there. You can do this with everything from TikTok to Snapchat to Facebook to Google, and you would do a Google takeout. They request their data. Typically, your wait time is between 24 to 48 hours. Some of them, it might take them up to a week to do the full collection of your data. Most of the time, I get it back within 72 hours. That's been the longest I've had. The data is delivered back to the person who requested it in a link to their email, and then they can go in and download it. Again, you're working in cooperation with potential client or a suspect. They're kind of the same thing. This is an example in Facebook, and again, the interface changes all the time, so keep that in mind. It almost always is in the security, and it's a request your data has now been the common terminology that it's deciding to use. The difference in between this data versus our smartphone data versus our cloud data is this literally represents 100% of your data almost. I'd say it's like 99% of your data from the point you started that account. So this is the largest representation of data that you can request. For those of you who might be in law enforcement, this is actually a larger data request than what you get with a search warrant request, or sorry, when you subpoena the data. I had a brain cramp there. This has more, and I say that because here's a good example of Facebook here on the screen. Notice how it has things like likes and reactions. So this can tell when I liked what my sister said versus when I did not like what she said. Little things like that are actually logged and kept, and when I go for my compliance data, that information is available to me. It is not available to me in the general app store as far as the information that comes from my actual mobile device, and it is not available to me in my cloud store. This is something that they have available to them in their backend servers, that this is the only way to access that information. Lots of good pieces of information, lots of good areas for you to collect from, all of them really in another location. At the end of the day, when you guys start thinking about cloud forensics, because sometimes I think it can come across very intimidating, especially when you start thinking AWS and Azure in a complex environment, is really cloud is just someone else's computer. The difference is in digital forensics, we're not going to have access to that physical computer. So we have to go through those extra steps that I've mentioned that allow you to still do a proper forensic collection. As far as big cloud, it's all of them. In order for you to get, there aren't logs associated with little cloud. So with big cloud, you want to get all of them. The reason is that's what's going to give you your map to the primary data areas that you are seeing use in that you would collect. Because again, you could end up with a petabyte of data pretty quickly in a large cloud environment. So that's going to tell you this is the primary S3 bucket that was being used at the time of an incident that you might be doing a collection. That's going to give you the map. So you have to collect all of them. When you're doing big cloud, then it's actually not that hard. I know it feels hard because, again, it's an environment you're probably not in every day, and they have the worst interface to be able to interact with it. But being able to make copies of buckets is actually really easy, and those count over as forensic images, because once you have your bucket, then you process it within your forensic tool in that environment. Your forensic tools that can do remote imaging, that's typically how you would actually do your capture within AWS or Azure. I actually haven't done an Oracle capture. I haven't had any clients that needed that yet. So, and my company is based in Azure and AWS. So I will set up a virtual machine with my forensic tool running. Their cloud environment is going to still be running in the time that you're doing your collection. You can't have someone take down all their architecture and shut down their company in order for you to do forensics. So it's very much a live forensics situation. That's when you're usually going to use a particular agent within their virtual machine, and then you're going to do your imaging. So you can practice what you would do in the cloud within a structured environment that you might set up in your lab just by doing a small network and doing your remote imaging. It feels and works the exact same way. It's actually a little faster. That's a tough one. If the data is compromised, that's when I have to think of how I would want to do that. Typically, if I have ransomware that's already executed within my cloud environment and they don't have any backups, that's crazy rare that they would have nothing as a backup within that environment, because it's something that you can set up within the environment itself. That's when I would work with the large cloud provider, because they do have a response plan when they have ransomware or execute within their cloud environment. So AWS has a separate team, Azure has a separate team, and they have a set protocol that goes through. I believe their protocol is that they actually bring down the data. So you're going to have to do the more expensive option and actually bring down a copy of the data if you've got ransomware that has been executed within the cloud environment. But they do have, and that is something very important. I didn't have a screenshot of that or anything, but all the large cloud providers do have a set incident response plan when something has executed within your cloud environment. I know that as a user of their cloud environment, so that I can set a policy for my cloud as well, but they have response teams within all of those organizations. The problem is, something's going to happen and you're going to be called in to do an investigation probably up to like 30 days or longer after something has happened. I would review what their policies are to see if they do take backup snapshots associated with anything. A good example is, for example, I have my machines that snapshot to another cloud environment from a cloud environment. So find out all the policies associated with it. That's kind of the same as building that map of the cloud environments with all of the logging associated with it. That's really going to say, this is my approach that says this is the most possible data I'm going to get, and then have a second and third approach. You might be down to your third approach, which is this is your only choice that you have, is you're looking at a bunch of fragments and you're not going to be able to put together a whole lot. But I very rarely, I think a lot of us get into that habit that says, okay, I've had something happen, so I have to take everything offline, and now I'm going to start reviewing everything, figure it all out, and then I'm going to bring it back online. That's not possible with big cloud because you're taking down the operations of an organization. They very rarely can afford having everything that they have associated with their large cloud environment just off, because it's going to cripple their company. So that's when you're very quickly making those copies into the same cloud environment and just adding to additional services in there, getting extra buckets, copies of the buckets. It is very fast as long as you stay all virtual. It's when you take and say, I want to pull down 4 terabytes of data, that process is actually fairly long in comparison. One, I can get an entire cloud plan in place and executed within a day. The other, it's going to take a week. So keep that in mind when you're deciding how you want to deal with it in a large cloud. Oh, they made some bad choices. The hope is that they're actually making those decisions. If you're part of the decision-making process, obviously logging is your mapping. So you want to have all of that started within those cloud environments. And that's the other side of digital forensics, is you become part of a security team. Like, you're kind of the response side of that security team. And you have to make those recommendations that says, hey, if there is ever a problem with the cloud and I have to do an investigation, I need these services turned on. The nice thing is that the services we use to create our mapping within our cloud capture are not expensive services in comparison to some of the other cloud services, if that makes sense. It's not like you're asking for a massive amount of storage or anything else with it, but have the policies adjusted and changed. If they have no policies in place and they haven't turned any of that stuff on, that is when you need to make sure you're capturing, looking at that bill that they have, since we're talking large cloud, and saying, okay, well, how many virtual machines do they have? How many buckets or blobs do they have? That's where you're going to have to start from. And I would actually start from the virtual machine, because that's going to tell you some of your architecture of how it's actually working. Hopefully they have that mapped out, but you never know. And then I'm going to go to the buckets or blobs, which is just data. And then I'm going to work from there. Yes, when you image, because you're working virtually, you're working with a virtual machine. So a virtual machine is really simply a file. It's the same in the cloud environment. And so you taking a copy of that file can still be a viable forensic image, because once you bring it into your forensic tool to be able to do your analytics within that cloud area, you're still doing all your appropriate hashing and everything else associated with it. You just have to not think of it as, oh, I'm not gaining access into this hard drive, because it's not one hard drive that virtual machine might exist on. It could be spread over a large number of drives. So you're really working with files. I know it's hard to kind of change your mentality, because you're going to end up looking at a virtual machine in the end, and you're going to look at a full file structure and everything else. But really, when you think of the cloud, whether it's a bucket or a blob that are just a collection of files, or I'm looking at a virtual machine that is just one file that represents a machine. I'm really doing file forensics, if you want to think of it that way. So all your verification, it is a full file system because it's all contained within that individual file. So it's just not traditional forensic imaging. I'm not going to say, oh, it's a bitstream copy. It's a virtual machine. Of course, it's a bitstream copy as soon as I have the individual file. And I put this out as a challenge to all of you. When you request your compliance data, the reason it helps the user on their privacy, as an individual, I actually collect all of my compliance data once a quarter. And I do that because that's allowing me to see what my potential digital fingerprint is with every app I use, with my Gmail, because almost everyone has a Gmail at this point. You know, all of that information comes together. That's really showing me a representation of my digital fingerprint. And when I do it in a forensic process, that's the same thing I want to see. I want to see the scope of what their digital fingerprint was, where potentially was, let's say, a stalker might be finding their information and following them around. Do they have location services turned on, but it's not showing in the app data? But when I look at the compliance data, I see that it's trailing out all their location information. It's giving you a deeper scope on what they use to function in their life, because we all use apps every day. As someone who's been a software developer for my career, I hate calling programs apps, but the fact is, if it runs on a smartphone, it's an app. And that's how people function throughout their day. They don't sit and use the phone to make phone calls. They're using it to work in different apps. That's increasing or decreasing their digital fingerprint depending on use. I think a good example of that is Snapchat. So Snapchat on the smartphone itself has very little data. Like, it's designed to hide the data. It's the whole function and purpose of Snapchat at the end of the day. But when I look at the compliance data, I then can see who we were sending images back and forth with. It still doesn't have the images. That data is actually destroyed as part of the functions within Snapchat itself. But I see whether or not the person I sent the image to opened it. Did they see it? How long did they have access to it? All of that information, which I would call metadata about that image being sent, is maintained within their compliance data. Where if I look at just the app data itself, I get very little information. And it's kind of disappointing, honestly. So this is a great way to get that larger scale scope. It's also a great way, and my challenge, as I started this with, is go through and collect your data. Your data is actually the best practice that you have to do digital forensics, because you're investigating data you understand. So request your compliance data, see how quickly you get it. This is going to give you an idea of how it would be in a live case scenario. And you can go through and practice with it. You can download forensic tools, the commercial tools, like my tool will allow you to review your compliance data for free. So you can go through and download it and use it in its free version and actually start doing the analytics, create that map, create a report like you would to a client. Because the hardest problem you have in getting a job in this space as far as digital forensics is they always want you to have experience. And you're like, well, how can I get experience if you don't hire me? And this is where you have to kind of create your own experience. Have a project like, I review my digital fingerprint, the digital fingerprint of my families. This is my forensic workflow I go through to be able to do that. That's showing that you're putting practice into practicality and putting it into a project, different things like that. I think that's an area on a lot of people's resumes that they don't do well. I want to know what kind of projects you've completed, what kind of investigations that you've specialized in. Do you do a lot of ransomware? Have you designed a forensic workflow from start to finish for an organization? All that is crazy important when it comes to wanting to get a job and having experience. Your tool is somewhat irrelevant as long as it has the functionality. So if I'm doing cloud and big cloud, I need to have a tool that has some type of remote imaging capabilities. It has to be able to open up different virtual machines and obviously understand the file systems associated with the cloud, which are primarily going to be Windows, Linux, and Unix. So as long as my tool has that functionality, I should be able to run it within the cloud. Now, the part that gets you is that some of those tools out there that are commercial tools now all of a sudden tell you that now you're buying an enterprise version of the tool. So you have to be charged like $1 gazillion to be able to use it. That is not the case. You're really not changing the scope. Again, just think of it as you're looking at a different network. It's not that crazy. So being able to make copies within that environment, it's really not that big of a deal. You can actually do all of that acquisition stage. So make copies of the buckets, make copies of the virtual machines with the functionality that's built into the cloud. Then you have that moment that says, am I going to pay to download it, or am I going to work virtually? So that's where you get into the commercial tools. Does their licensing allow you to run on a virtual machine? Different things like that. You'll have to ask those kind of questions. But I don't think it's tool specific. Just don't get caught up in a lot of marketing that says, oh, to work in the cloud, it has to be an enterprise tool. It doesn't. It just has to be able to do some basic remote imaging. That's it. Obviously, in digital forensics, you always use more than one tool to be able to do anything. It's just kind of the rule of thumb for it. As a tool manufacturer, obviously my primary tool is mine. So I use the E3 forensic platform. That's what Peregrine produces. That's what my company produces. I use that for doing the cloud because it has remote imaging with it. It reviews virtual machines. It understands Linux. It understands Windows. It understands Unix. So I can use it throughout my entire process. Then I'm going to go through and pick a secondary tool that's going to review the data I collected after. You really only have to have a primary tool for that collection aspect of it. The only reason you have two tools in digital forensics is for the review process, because every tool manufacturer has different research that goes into their tools. So you might see a different structure produced from one tool than you do the other tool. So that's why you do that in the analytics. But for doing the actual collection side of it, you just have to have one core. Obviously, I use my tools as my primary. That makes sense. But there are a lot of other good tools out there. You want to pick one that fits within your budget, because you don't want to spend all your budget on a piece of technology. They want to spend it on you and your salary. So make sure when you become familiar with tools, you're picking things that are going to not compensate for you because they're so expensive. They're going to enhance the skills that you have. So go out and research them. That's actually a great challenge to go through and use some of the AIs for. I use Perplexity when I do a lot of my AI research. It will tell you some good recommendations on what tools have that functionality with it. And it's a great place to start. Ask for trials, do some practice. Microsoft Azure does a lot of free cloud space and free cloud trials with it, where it gives you a certain number of credits. Again, everything gets charged in the cloud. I think it gives you like $100 of credit when you sign up for a certain type of account. Use those to get familiar with it. Resume Booster, being familiar with AWS and being familiar with Azure, I'm going to pick the two big primes out there, is going to help your resume, because a lot of people are intimidated by it. And there are a lot of courses out there that you can take, and there's a lot of opportunities where you just have to get familiar. You just have to play around in it. It will start clicking for you when you start seeing that architecture. Don't be intimidated by cloud, especially big cloud. I think that's very hard. Sign up for an account and see and look at what your bill would be like, so you can understand examples in those areas. You have to experiment. That's all your tool providers do. That's all the providers do in general, is they experiment and try it. So if you don't try it, you're never going to understand what it looks like in those logs. You've got to practice, and that experience will show on your resume. It will be a big help.